Thanks, everybody. Good morning. So this is really what I've been nerding out on the last year or so. I found out about Bitcoin in 2012, and at first you think it's a currency, and you get excited by the fact that here's a currency that can't be manipulated, that's completely transparent. But soon you realize that Bitcoin's more than a currency. It's a payment network. And this payment network lets me send money all around the world instantly with the click of a button. And that's really interesting. But as you go up the learning curve, the third thing you realize is this is more than a payment network. This is more than a currency. This is actually a new model for building projects. And so that's what I ended up describing in this white paper about decentralized applications, is what I think the 4 keys are to the success of the Bitcoin model. And so real briefly, I'll just go over those 4. I think part of the reason it's caught on so much is this is an open source project. It's not a proprietary company. It's not a proprietary standard. This is something that everybody can contribute to as a developer, as a coder, as somebody that wants to add to the network. And that openness really made it powerful. It's similar if you look at the early days of the internet, there were a lot of competing technologies. What won out at the end of the day was HTTP because it was an open standard, no one company owned it, and that gave it appeal to a very broad audience. And so I think that's the first key you have to understand, is the future is in building open source projects. But it just wasn't any open source project. It had a new innovation. It had this digital token attached, that you needed this digital token to access this application. If you try to send Bitcoin across the Bitcoin network, you can't use Litecoin, you can't use Feathercoin, you can't use any other coin. Only Bitcoin is recognized as a valid transaction to go across the payment rails, if you will, of the Bitcoin payment network. And that really gave this open source project a price and a value, because all of a sudden you had a limited supply of these tokens, and as more and more people began using the payment network, all of a sudden there was more and more demand for this limited number of tokens. And so over time, as there's more adoption, you see the value of Bitcoin increase over time. And there'll be fluctuations, but if you look at a comparison to something like Metcalfe's law and the network effect, there's a pretty high correlation between adoption of this payment network and the value of the currency. So that's the second thing. It had a digital token that gave these features and access to this application a market price. The third big innovation was the fact this is all peer-to-peer. There is no center. All the records are spread around the network. Everybody has a copy of the Bitcoin ledger, all the transactions that have happened. And this is really a great way to prevent a central point of failure. If you have a central server, at some point it will get hacked, or it will be taken over, or it'll go down because the power goes out. Here you had a structure where tens of thousands of nodes have a copy of all the Bitcoin transactions, and it has built an incredibly resilient network that keeps operating. So that's the third item, decentralization and storage of all this data. And the fourth is the idea that we're going to connect this system to a proof of work. Now, this proof of work serves as a consensus mechanism that says we can cryptographically prove that a particular node has added value to the network. And in the case of Bitcoin, all the miners are adding security to the network by adding more hashing power. As many of you probably know, the only way to falsify a transaction on the Bitcoin network is to have at least 51% of the network power. And so by incentivizing miners to add more and more power to the network, you protect the network from bad actors, whether they companies or nation states or malicious miners that might want to mess with the network. That's become largely impossible due to the scope and scale of the hashing power now applied to the network. So these 4 things, again, the idea that it's built on open source, not a proprietary standard. It's got a digital token to monetize the use of that application. It's got decentralized storage of all its records, and it has a consensus mechanism, has made Bitcoin this incredible monumental force in its own development. It's attracted some of the most brilliant people in the world. It's attracted tens of thousands of miners to contribute to it. But the interesting part for me was this idea that this isn't just a one-off. Bitcoin isn't the only thing that could ever use this model, but instead that this was a general theory for we can build decentralized applications like Bitcoin that are doing things other than currency and other than payments. So I'm not talking about alternative coins that are doing other payment networks or other currencies. I mean applying this model to different parts of and different technical verticals. And so I started imagining, what if you could reward people for contributing storage to a cloud? So sort of like the reverse of Dropbox. Instead of getting charged to store things in the cloud, what if I could get paid to put my extra computer space onto the cloud? And I got paid in the form of a digital token. And you use this Bitcoin model where everybody in the network was a node. That would be radically cheaper than Dropbox or Google or other storage solutions today. And I began thinking generally, oh, we can apply this not only to storage, but to computer power, to bandwidth and sharing the internet. And it really opens up this whole suite of infrastructure level applications and protocols that can be built if you apply the economics of this model and you structure it in the correct way.